Welcome to the Flip class. I will speak about CodeBert, specifically about main approaches behind code2vec and CodeBert. Agenda. Some general introduction about code-embeddings, code2vec model, CodeBert model, and some comparison between these models. Introduction. Code-embeddings are vector representation of source code that enables machine learning models to understand and process code. They transform code into numerical formats, capturing its structure, syntax, and semantics for tasks like code search, summarization, and generation, with possibility of creation as a task. Code2vec. Code2vec uses abstract syntax tree or AST paths. The abstract syntax tree is a tree-like representation of the code, where nodes represent constructs such as functions, variables, operators, and control flow elements like loops, conditions, etc. Edges represent the relationship between these constructs. Path is a value from one leaf to another. Path context vector or path context is a tuple that considering ending and starting tokens in the path and the path itself. From single AST, we can sample multiple paths, and the model uses about 200 paths. Model target is prediction of the function name given the function itself. More specifically, path contexts are sampled from the AST. Code architecture is quite simple. Model gets as input context vectors that processes with fully connected layer. Then these vectors are combined into the final code vector with considering of the aggregation via attention mechanism. As a model input, we create a ST path context vector or token ST path and token, where token is a start and ending token in the IST path. We aggregate these tuples using attention and update code vector, where code vector initially initializes in random. We use softmax for function name prediction and cross-entry loss used in this training method. Researchers showed the importance of all of these three elements in the model work, where you can see on the table appearance or disappearance of some elements in this tuple on the work of the final model. Tuple of three elements starting, path vector, and ending tokens represent the best model metrics. Code2vec results. Model learned to predict function names based on their properties, and the model showed understanding of some functions names, properties, and their correlation between each other. So model could predict some new function name based on values of other parameters such as get plus value, its function get value, or creating semantic analogies between method names, such as open plus connect is similar to connect or disconnect. CodeBert. CodeBert based on the Roberta model, which is based on the BERT model. BERT model considers two masked sentences as input, a masked sentence A and a masked sentence B. CodeBert considers of using two model inputs or B model inputs, in case of B model inputs as natural language and programming language pair, and natural language pair for unimodal and programming language for unimodal as well. Model learns to represent contextual vector of represent each token. Model learns to output contextual vector representation of each token for natural and code languages, and the representation of the CLS token, which works as aggregator of the secondary representation. CodeBert uses bimodal input as natural language and programming language, and unimodal data as natural language, and programming language pairs. Natural language represented as code documentation, and programming language as code itself. Code was taken from the top GitHub repositories with quite well documented code, and if documentation of the code was quite large, it was shortened to specific len. Model was trained with a cross-model style training, where model used bimodal and unimodal training at the same time. Masked language modeling was used for unimodal data, where some tokens in the sentences of natural language or programming language were masked out with a mask token and then replaced with mask. So model should predict the original token from the context. As you can see, CodeBert with MLM performed quite well compared to the Roberta model in the token prediction in natural language and programming language. Replace token detection or RTD. In this task, the discriminator is trained to determine the word in the original one or not, which is a binary classification problem. As input, model discriminator takes two sentences or two inputs as natural language and programming language, where some tokens were replaced by specially created natural language and code generators. These generators take as input inputs of words and code, which some tokens masked out. Here you can see the illustration of this process. CodeBert results. CodeBert showed great results such as excellent natural language code search, natural language programming language probing, and it was even experimented with code generation, and they showed quite great results since this architecture is not considered to generate code. And CodeBert showed great results in the work with C#, since C# wasn't used as a language it was trained on, and it showed results compared to the SOTA models with similar tasks. Code2vec and CodeBert comparison. CodeVec captures code structure using ST paths, and it's a really simple, lightweight model. It's useful for syntax-driven tasks such as function name prediction and code property prediction. For its cons, it's sensitive to variable naming, lacks of global context for larger codebase, and cannot model the relationship between functions really well. So CodeBert, for its cons, it captures deep contextual relationship in code and pairs of natural language and programming language really effectively, and generalizes well to unseen programming language as experiment with C#. As cons, it's quite computationally intensive, but nowadays it's not that problem as it was 4 years ago. But for training, you need quite a lot of resources compared to the code2vec model. And CodeBert struggles with large complex code bases, and it cannot really generate code as it shows that it's capable of it, but it's really bad at it. And the references that were used to create these flipped classes. Thanks for watching.